The following factors affect the accuracy of thermogravimetric analysis results. The first and the most important factor is the heating rate. Heating rate has been found to affect the thermogram appreciably. The effect of heating rate is important if the thermogram is used for kinetic analysis. In the above figure, the effect of heating rate on the thermogram of calcium oxalate monohydrate has been shown. The plateau from the room temperature to 100 degrees centigrade corresponds to monohydrate. The loss of carbon monoxide commences at a temperature of 413 degrees centigrade, and that of carbon dioxide commences at a temperature of 685 degrees centigrade. Now, it is evident that these three reactions, dehydration, loss of carbon monoxide, and loss of carbon dioxide, at lower heating rates have lower onset and decomposition temperatures. Similarly, on heating nickel sulfate heptahydrate at a rate of 2.5 degrees centigrade per minute, only one plateau in the thermogravimetric curve corresponding to nickel sulfate monohydrate is obtained. But when the heating rate is at a value of 0.6 degrees centigrade per minute, the curve breaks into several plateaus indicative of nickel sulfate hexahydrate, nickel sulfate pentahydrate, nickel sulfate tetrahydrate, nickel sulfate trihydrate, nickel sulfate dihydrate, and nickel sulfate monohydrate. These are obtained. The second factor affecting the thermogravimetric analysis is the heat of reaction. The heat of reaction will affect the difference between sample temperature and furnace temperature and causes the sample temperature to lag behind or lead the furnace temperature depending upon whether the reaction is endothermic or exothermic in nature. When the reaction is endothermic in nature, the effect of temperature lag is to increase the furnace temperature, and the differential temperature is additive in nature. But when the reaction is exothermic, this effect tends to compensate each other. The next factor affecting thermogravimetric analysis is the measurement of temperature. The usual practice in thermogravimetric analysis is to measure the temperature in the furnace near the sample. The temperatures so determined in this manner are usually higher than those determined by the more common process of measuring the temperature directly. The cause of this difference is partly due to the thermal lag and partly due to the finite time required to cause a detectable change in weight. When the thermobalance is used to study the drying of bulky precipitates, it is well to use slow rates of heating. The next factor affecting thermogravimetric analysis is the effect of atmosphere. When a sample is dried in thermobalance, the atmosphere near the sample is continuously modified due to the addition of gaseous decomposition products or the loss of the part of original gas by reaction with the sample. Even small changes in composition of this atmosphere can affect the thermogram. It is therefore necessary to flush the thermobalance continuously with inert gas in order to maintain constant atmosphere. The next factor influencing the thermogravimetric analysis is the effect of changing air buoyancy and convection. The most favored arrangement for thermobalance is to support the inert sample from below in the center of a cylindrical furnace. Under this condition, the inert sample shows an apparent weight gain up to 10 milligrams. Correction is applied to the recorded weight change. The causes for the apparent weight gain are decreased air buoyancy, increased convection, and the effect of heat on balance mechanism. The magnitude of the apparent weight gain is reduced considerably by proper venting. The last factor influencing the thermogravimetric analysis is the sample characteristics, which includes weight of the sample, compactness of the sample, particle size, and history of the sample. A large sample affects the thermogravimetric analysis curve, and the curve deviates from linearity as the temperature rises. Hence, small samples are preferred. Compact samples decompose at higher temperatures than the loose sample. Smaller particles decompose at lower temperature, while larger size particles take longer time and decompose at higher temperature. The source and method of preparation of the sample also affects thermogravimetric analysis curve. For example, precipitated magnesium hydroxide decomposes at a different temperature than the naturally occurring magnesium hydroxide.